All right. I want to give you some time to work on this. Here's a function, y equals f of x. It's a little bit hard to see on my graph here. Let me fill it in. The other thing that's a little bit frustrating, I still haven't gone in and fixed this. I don't know why. That's 1. There's 2. There's 3. There's 4. There's 5. I don't know why I don't have a scale on there for the rest of the numbers. Okay. What I'd like you to do is try to sketch the derivative of this function. So you're going to sketch a brand new graph here, right? Now what does this graph tell you? At each x value, it should tell you the slope of the tangent line. Okay? I'll do one with you. Okay? At this point right here, if I drew a tangent line, what's the slope of that tangent line? It's negative something, right? I'm not exactly sure, but it's negative something. So at x equals 0, the derivative should have some negative value. Okay? Notice I didn't, I guess I did put a, I don't know why there's a 1 up there. Pretend there's no scale on that. So go ahead and sketch this. Talk with your neighbors. See if you can come up with it. This is a challenging skill, but it is worth putting in the time now to learn how to sketch a function's derivative just by looking at the function. Folks, one of the things, and I didn't tell you this initially, I think you'll find it helpful though. Go through and look at where you have horizontal tangent lines. What is the derivative at each one of those purple points that I put up there? 0. At each one of these, f prime of whatever that number is, let's just call it a, it should be 0. Because the slope of the tangent line is 0. Okay? So what should the derivative value read? Let's go ahead and put x here. This is f prime of x here, right? Okay. So when x is, where is that? Well, on my scale, which isn't necessarily right, somewhere just a little bit beyond 3, it should output a 0 for that point there, right? And let's go ahead, I'll change this one to a red. Where is that? That's about 1.5, right? At 1.5, we've got another horizontal tangent line. So what should the derivative output at 1.5? It should output a 0. Okay. At this point right here, we've got a horizontal tangent line. So that's at about 0.5. So at about 0.5, we should output a 0. Now, before we got to this 0 right here, the slopes of the tangent lines were all what? Negative. But as we got closer and closer to the x value 0.5, they started to level off. Do you see that? Which means they've got to, although they're negative, they've got to start getting closer and closer to 0. Now, just beyond this point, just beyond 0.5, my tangent lines all have a what slope? So the derivative needs to return a positive number until we get to 2. Or excuse me, until we get to 1.5. At 1.5, we need to again have a 0. Okay. And then we come down and we go up. Now here, this is sort of starting to increase at a constant rate. So this really should sort of start to level off like that. You don't want it taking off like that because that would be saying it's continuing to increase at an increasing rate. And I don't think that's quite what's happening here. Anyway. Okay. Folks, this is a good skill to practice. Okay? I said it once before, I'll say it one more time. It pays big dividends to get good at relating the graph of a function to the graph of its derivative. The better you can understand that relationship, and it's really just an intuitive relationship that you develop over a long period of time, okay? But the better you can create that relationship, the better you can understand that relationship, the better the next 2 chapters will go for you. I promise. Okay? So let's look at this one.